Welcome back to our course on disaster management. I am Dr. Nagalapuram Muni Pradeep, Assistant Professor, Department of Civil Engineering, SR University. Today we are discussing about part 2 of lecture 2, key concepts, that is disaster, hazard, vulnerability, risk and capacity. So in part 1 we discussed about the in detailed explanation of hazard, disaster and the definition of vulnerability. In this lecture I'll explain the vulnerability, risk and capacity. Okay, so why I made part B, because it was very lengthy lecture. I just want to keep it simple. So coming to this portion, this lecture is talking about types of vulnerability. So this slides presents a comprehensive classification of vulnerability into 9 types. These 9 types are directly sourced from IGNOU 2006. So let us go through the each type and real world examples. The first one is material or economic vulnerability. The first one is material or economic vulnerability. So I'll explain the type of vulnerability as well as nature of that vulnerability. So the first one is material or economic vulnerability. This vulnerability refers to an inadequate access to financial resources. So poor communities cannot afford strong houses, insurance or recovery assistance. So they are economically vulnerable. So after a disaster, they take much longer time to rebuild because they have no savings or no assets to fall back on. So this is comes under the material or economic vulnerability. Second category, that is social vulnerability. So this vulnerability refers to the disintegration of local institutions and local structures. Communities with strong social bonds, active neighborhood groups, functioning panchayatis and mutual support networks, they recover very fast from the disasters because they help together. They are acting together. The communities that are socially fragmented are very far, these are far more vulnerable because they are highly affected because they don't have any support system from the community. The third category one is ecological vulnerability. The degradation of environment increases vulnerability. I'm repeating, the degradation of the environment increases the vulnerability. So the main thing was deforestation. So the deforestation removes a natural buffer against landslides and floods. So destruction of mangroves removes coastal protection against cyclones and tsunamis. So a community living in an ecologically degraded environment is far more exposed to the hazards. So that is the third one, ecological vulnerability. And the fourth one, organizational vulnerability. So this is due to the lack of strong institutional structures at the central level, state level, and grassroots level. If there is no district disaster management authority, there is a term called DDMA. I'll explain in the coming classes. So what is the DDMA means? Um, if there is no district disaster management authority, no trained NDRF team, and no functioning emergency services, the community is organizationally vulnerable, most vulnerable society. And the fifth one comes under educational vulnerability. Insufficient access to information and knowledge. People would not know what to do during an earthquake, a flood, or a chemical spill are far more likely to die or to be injured. So the disaster education is a direct tool for reducing vulnerability. You can see in if you take the COVID-19 pandemic, a lot of misinterpretation is transferred between the spreading through different social media. So people are more panic about this because of these false news only. So that educational vulnerabilities, that comes under educational vulnerability. Next one, attitudinal and motivational vulnerability. So the low levels of public awareness and unwillingness to change behavior. For example, people who refuse to evacuate when warned of approaching a cyclone. For suppose in many coastal areas, the government is giving warning signs. You evacuate this place, there may be chances of hitting cyclone. But because of the low attitudinal behavior, so they have survived previous cyclones also. What they think, okay, last time also we were hit by the cyclones, but we survived. Like that, in that they are in that mindset. So they're attitudinally vulnerable. So changing this mindset requires consistent community engagement and education. This is very very dangerous. And next one is political vulnerability. So there is a limited access to political power. So marginalized communities such as tribals, Dalits, migrants, women, they often have no political voice to demand safer infrastructure, better warning systems, or post-disaster compensation. So their political exclusion makes them more vulnerable. And next one is cultural vulnerability. So there is a concept called blind faith. So the blind faith in beliefs and customs that prevent rational disaster responses. For example, communities that refuse to evacuate because they believe their deity will protect them, or who attribute disasters entirely to divine punishment. So cultural sensitivity combines with scientific education is needed to address this. And ninth one is physical vulnerability. So this is the main thing everybody is talking about, that is physical vulnerability, weak buildings and weak infrastructure. This is the most direct form of vulnerability. Poorly constructed buildings collapse in earthquakes, floods and cyclones, while well engineered buildings survives. As a civil engineers, because I'm belongs to civil engineering domain. So as a civil engineer, this is a form of vulnerability that we are most directly equipped to reduce. This is in our hands, this is in our civil engineering hands. So we will construct the infrastructure, we are introducing the reinforced earth buildings. So we are introducing resilient infrastructure to withstand all kind of disasters, right? So coming to the next slide. So coming to the next slide, this slide is about risk. So you know what is the meaning of risk. So here I'll explain in detail. So risk is precisely we defined as the probability of harmful consequences or expected losses, that may be deaths or injuries or property or livelihoods, economic activity disrupted or environmental damage. These all are resulting from interactions between natural or human induced hazards and vulnerable conditions. So we discussed already, risk is expressed by the following notation: risk or disaster that equal to hazard probability into vulnerability. Depending upon the probability, the risk will be converted into disaster and it will be converted into catastrophe. Okay, so the general expression is risk that is equal to hazard probability into vulnerability. So the probability will be less, then this is risk only. The probability is considerable value, that may be converted into disaster, and it is high value, high intensity, then risk is converted into catastrophe, right? So coming to the next slide. So this slide, I'll explain the risk in detailed way. So officially now we come to the fourth key concept, because till now we are discussing about disaster, hazard and vulnerability. The fourth term now, risk. So after understanding the hazard and vulnerability, understand risk becomes very logical, right? Risk in the concept of disaster management, it is defined as, so we discussed already, probability or likelihood that hazard will cause harm to the people, right? Right, the formula, everything I explained. So now I have to explain about cyclones in Odisha. That also we covered in the last class. So I'll quickly go to the next slide. That is risk perception. So the risk perception is a fascinating and very important topic. So we have defined risk scientifically. In the last slide, we defined the risk scientifically, but how do ordinary people perceive risk, and why does their perception matter? So this is the main. So in this lecture, we are talking about the risk perception. Risk perception is understand as the awareness of risk. How conscious a person or a community is of the danger they face. For suppose, so we are living in the coastal region where our uh, our area will be frequently hit by either cyclone or earthquake or tsunamis. So that we already aware of. Yeah, we may be, our place may be subjected to any kind of cyclone or tsunami or tufan, like we can say cyclone, tufan, both are nearly same, and earthquake. So the risk perception is not always inaccurate. People often underestimate, sometimes they overestimate risks based on their experiences, beliefs, and emotions. So this slide tells us that risk perception depends upon the four specific factors, right? So here, that whatever that risk, it is depending upon the that risk perception depending upon the four specific factors. The first one is exposure. The first one is exposure. This exposure refers to the actual quantitative risk level as determined through scientific risk assessments. So I'll explain in detail, don't worry. A person living on a floodplain has high objective exposure, but if they have never experienced a flood, their risk perception may be very low. So they may not feel at risk even though they scientifically proven. Second one is the first one completed, that is exposure, because they don't expose anything, so their probability will be very low. The second one is familiarity. Personal experience with disaster makes people acutely aware of the dangers. A person who survived the 2004 tsunami in Tamil Nadu will have a very high risk perception of tsunamis. They will evacuate quickly when they hear a warning because they already experienced this one. They are already familiar with that situation. In contrast, someone who has never experienced, for suppose if you take anyone born after 2004, they don't even have exposure what happened that time. So they have never experienced a tsunami, may not take warning very seriously. And third one is dread. The horror and the fear associated with the scale and consequences of a disaster, which increases risk perception. For suppose nuclear accidents, for example, are perceived as extremely high risk events, even though statistically coal mining accidents kill far more people. Right? Coal mining accidents will kill far more people, but still many people are interested to work in coal mines instead of nuclear reactors. So the dread of nuclear contamination and its invisible long-term effects amplifies risk perception far beyond the statistical probability. Even though the deaths are very less compared to coal mining accidents, but people are not ready to work under natural nuclear reactor area. And the final one, the fourth one, that is called preventability. So preventability, if people believe that a disaster can be prevented or that there be effective mitigative measures available, they are more likely to take action. I'm repeating, if people believe that a disaster can be prevented or that there are effective mitigation measures available, they are more likely to take action. So this belief in preventability leads to proactive behavior, that is evacuation or construction of safe houses, insurances to the people who are likely to affect this disaster. If people believe a disaster is fate or God's will and cannot be prevented, they will not be investigating mitigation. As future engineers and disaster managers, understanding risk perception is very crucial because you will often need to communicate risk to communities. If people do not perceive a risk, they will not act to reduce their vulnerability. So the risk communication, conveying danger in a way that motivates appropriate actions, is a key skill in disaster management. Coming to the next slide, that is risk identification and assessment. Now let us look at how we formally identify and assess risk in a scientific and systematic way. So risk identification is defined as process of finding, recognizing and describing potential risks that could negatively impact people or their property or their environment. So it is the first step in any risk management process. So risk identification answers these three fundamental questions. The first one, what can we go wrong? This involves identifying all possible hazardous events in a given area. I'm repeating the first question, what can we go? What can we go wrong? So this involves identifying all possible hazardous events in a given area. And the second question, where is the risk coming from? This involves tracing the source of the hazard, either it is geological or meteorological, industrial or biological. The third question, who or what might be affected? This involves mapping the population and the infrastructure in that hazard zone. So risk identification is done through either field surveys, nowadays with the help of satellite images, GIS mapping, historical disaster records and community consultations. So it is a multidisciplinary activity involving geologists, engineers, meteorologists, public health experts and social scientists. Once risks are identified, they are assessed, meaning their probability and potential impacts are quantified. A risk with high probability and high impact is the top priority for mitigation action. So before we draw the mitigation action, so we have to find out a risk with high probability and high impact. Right. So, so now I'll explain one case study. That case study is through flood risk. So in the case study of flood risks, so the risks identified. Seasonal flooding in a low-lying city neighborhood, right? Seasonal flooding in a seasonal flooding means in monsoon season. Seasonal flooding in a low-lying city neighborhood. This is a very common scenario across in Indian cities. Areas that are historically floodplains have been converted into residential zones without proper drainage and planning. So the main assessment probability very high during the monsoon seasons. This is not one-off event. It happens every year. So the probability is very high and very predictable. And the impact, so multiple types of damage. So houses are waterlogged and structurally damaged. There is no obviously the power supply is disrupted, and waterborne diseases like cholera, typhoid, and leptospirosis. There is one disease called leptospirosis. They spread among the population because of the waterlogging. And the main vulnerable groups, poor households who cannot afford waterproofing or relocation, children who are at the risk of waterborne diseases and accidents, because these waterborne diseases are spreading very fast in children's, kids and older people. And elderly people who have mobility limitations and cannot evacuate very quickly. From this assessment, disaster managers can prioritize improving the drainage, creating the flood shelters, and they're vaccinating the population against waterborne diseases and providing early warning system for monsoon flooding. So in monsoon flooding, people are aware of, okay, if this alarm will, we can hear this alarm means, so we have to be careful and we have to evacuate from this place, escape from this place, right? So now, one we discussed about one natural one. Now, second case study. It is a chemical leak in industrial zone. This comes under man-made or technological hazard example. So the risk identified. There is a gas leakage from a chemical plant located near a residential area. This is not a hypothetical scenario. This describes exactly the situation that can lead to Bhopal gas tragedy of 1984. So a union carbide chemical plant was located adjacent to densely populated shanty towns. So here risks are identified. Now coming to the second one, that is called assessment. So the probability is very low because major industrial accidents do not happen every day. But the consequences, if they do happen, is extremely high. So this is what we call a low probability, high consequence event. And this requires special attention. Now third one is impact. So the toxic chemical exposure causing immediate deaths, long-term respiratory diseases, cancer, and neurological damage, mandatory emergency evacuation of the surrounding area. So at risk, if you take at risk, who are in risk position, nearby residents, we have no knowledge of what chemicals are stored in their plant, and the factory workers directly handling the hazardous substances, and the hospitals that may receive the mass casualties but be unprepared for chemical burns and poisoning. So this case study illustrates why industrial safety regulations, community rights to know the laws, and emergency response plans around industrial areas are very, very critical, right? So these two, one natural and one man-made disaster. So we already in detail we discussed about the risk identification as well as risk assessment, right? Now I hope you understand what is the importance of risk identification and assessment. Next one. So coming to the next slide. So now risk also over, disaster over, hazard, vulnerability, and the risk. Now the final term, we came to the final term, that is called capacity building. We come now to the fifth and final key concept of the today's lecture, that is capacity. So capacity is the positive counterpart of vulnerability. So till now we are only discussing about the negative part, vulnerability. These people are most vulnerable people. So to counterpart of vulnerability, there is one more positive aspect, that is called capacity. This is the positive counterpart of vulnerability. While vulnerability tells us what makes a community weak, capacity tells us what makes a community strong. I'm repeating. The vulnerability tells us what makes a community weak. As a counterpart, capacity tells us what makes a community strong. So there is many definitions. I'll simply discuss two to three main definitions. The first definition: capacity is defined as the combination of all strengths attributes and resources available within a community, a society, or an organization that can be used to achieve agreed goals. I'm repeating, the capacity is defined as a combination of all the strengths, all the strengths, sorry, combination of all the strengths, attributes, and resources available within the community and within the society or within the organization that can be used to achieve agreed goals. So coming to the second definition, capacities are the assets, capacities are the assets, resources and skills available within a community or a society or organization that can be used to reduce the risks of or effects of disaster. So think about what gives a community the strength to face a disaster and recover. It is their financial resources, their trained personals, their functioning institutions, their social cohesion, and their knowledge of risks. All of these together constitute the capacity of what community. See, here I'll explain, I'll give you the one context. There is one movie called 2018. This movie was, movie name is 2018. It was Malayalam movie. So in that movie, the total coastal region of Kerala was hit by a cyclone, and before that NDRF, all state, central government response, the local fisher people, they responded they in a very quick way, and with the help of local support, instead of biggest disaster, it is the normal, they saved many people. So there may be infrastructure loss, there may be loss happen in economical terms, but in terms of lives many people saved because of the local active participation of local fishermen. So this is what um, capacity. So next term is capacity building, which is the process of strengthening this capacity. So here capacity building means we are not building any kind of infrastructure. So here the capacity building means which is a process of strengthening these capacities. So whatever that social cohesion, functional institutions, their knowledge. So this is strengthening of these capacities. Is therefore the capacity building is therefore one of the most important activities in disaster risk reduction. When we train community members in the first aid, like we give training to the local people about first aid, when we conduct evacuation drills, when we build cyclone shelters, when we enact and enforce building codes, we are building capacity, right? So in many cities, still people they don't know what is the building laws, and suddenly if flood happened, so many people they don't even know the swimming. So we'll conduct many evacuation drills, we'll build cyclone shelters. There may be cyclone shelters, but the local people they don't even know how to reach that building shelters. So when we strengthen these things, that is only we are strengthening the capacity, that is called building capacity. I hope you understand. Next, so next slide. So, what is the types and functions of capacity building? So, this slide expands on the concept of capacity by telling us what forms it can take and what functions it serves. I'm repeating. This slide expands on the concept of capacity by telling us what forms it can take and what functions it serves. So the capacity may include physical means such as well-built shelters, so emergency equipments and functioning hospitals. So it includes institutional means such as a trained NDRF battalion. See, if any such incident happened in Hyderabad kind of cities, so there may be NDRF battalion availability. But if same thing happened on a very remote areas, so that NDRF battalion is not ready to reach within that time. Okay. So that institutional means such as trained NDRF battalions, an active district disaster management authority. I'll explain in the coming classes what is this district disaster management authority, or a functioning early warning center. So there may be early warning systems, but that function is not there. So from where they will receive the early warning systems, right? These all comes under institutional. Institutional. Next one is social. The social means such as community self-help groups, women's collectives, and voluntary organizations, and it includes economic means such as crop insurances, emergency funds, and social security systems. So the capacity means the four categories. The first one is physical, such as well-built shelters, emergency equipments, and functioning hospitals. Hospitals are there; it should be functioning also. And second one, institutional, that is NDRF, state government, central government, how they are reacting, how they reach, and it is about the authority. Third one is Third one is social, which is the relation between the people as a community, how they're reacting, how they're growing. And the final one is economic, that is the insurance to those people, and there is an emergency corpus fund and social security systems. So these four are the which includes the capacity buildings. If you are strong in these four categories, then you are building a very strong capacity, right? So coming to the next slide, you can see here. So here till now whatever we discussed, I'm visualizing these capacity buildings in these figures. So this slide presents three photographs that visually illustrate capacity buildings in an action. The first photograph, you can see the first photograph shows first aid training center being given to a community members. You can see the first one, the first aid training to the people. These three images I have taken from three different sources. These three I am taken from the same source, that is preparecenter.org. Okay, so the first photograph shows first aid training being given to the community members. This is capacity buildings at the grassroots level. When ordinary people know how to perform CPR and they know how to treat wounds or assist a drowning victim, the community's capacity to respond to emergency increases dramatically. In the critical first hour after a disaster, before professional responders arrive, it is often ordinary community members who save the most lives. As I discussed already, 2018 movie. This is what the meaning is. See, mm, many professional responders, maybe central government, state government, they respond after at least minimum to minimum 12 hours, 20 hours. So in that first hours, how the community is reacting, that is only saves more number of people, lives. The second photograph shows cyclone relief center. You can see the second one is cyclone relief centers. The concrete multi-story building structure building along the coastlines of Odisha. This was a picture taken from the Odisha. And these kind of structures, many structures were constructed in Odisha, Andhra Pradesh, and Tamil Nadu, specifically to shelter coastal population during the cyclones. So before the monsoon period only, the government gave alerts to the people. So those people, they will come to these shelters and they lived here for minimum 2 to 3 months. After that monsoon period will over, then only these people will return to their original places. So Odisha alone has over nearly 880 such shelters in only Odisha. So these physical structures represent enormous capacity investment by the government. Look, especially the Odisha Disaster Management Board is one of the best board in the world. So the difference they make in saving lives during the cyclones has been proven repeatedly. You can see the third one. The third image represents capacity building in a broader sense. The first one is about training. The second one is about cyclone relief centers. And the third one is about the capacity building. The community training, the awareness programs, the mock drills, and institutional preparedness exercises. These all are comes under broader sense as a capacity building. So these are not dramatic visible structures, but they build the human and organizational capacity that is equally essential. Um, See, I'm a belongs to civil engineering category, so we are directly involved in designing and building the physical capacity buildings, cyclone shelters, flood embankments, earthquake-resistant buildings. So, compared to other departments, the civil engineers are more connected to this capacity building because we are the one who build the infrastructure, right? So, coming to the next one. So this slide presents the extremely important diagram from the research of right. This diagram, this slide presents an extremely sorry, I forgot the source. Just give me a minute so I can recollect. This slide presents an extremely important diagram from the research of Dhalla and Esmail. This is published in 2018. This diagram shows the four stages in the evaluation of a disaster. That is called hazard, risk, emergency, and disaster. Let us understand this progression carefully because it tells us at which stage we can intervene to prevent a disaster. The first one is hazard. At this stage, we have a natural or man-made phenomena, either an earthquake fault or an active cyclone in the Bay of Bengal or a chemical plant near a residential area. The hazard exists but has not yet interacted with the vulnerable community. So this is the best time to intervene to through land use planning, hazard zoning, and risk informed construction. Now, second one is risk. At this stage, the hazard is now interacting with the community that has some level of vulnerability and exposure. So the potential for harm exists. So here the risk means there is a potential for chances to harm exists. So this is the second opportunity for intervention through the risk assessment or early warning systems and community preparedness, and will give training. Third one is stage C is emergency. At this stage, the hazard is now interacting with a community that has some level of vulnerability and exposure. So the potential for harm. So here also there is a potential for harm exists. So this is a sorry. So I talked about the risk only. That's a stage C was emergency. So in this stage, the hazard has now struck. So immediate harm is occurring. There is a chances of immediate harm is occurring. So people are injured, trapped, or cut off. Emergency response is activated, and search and rescue, medical, medical aid, evacuation, and communication. See, the second one is risk. There is a chance. Now, stage 3 was emergency. In this one, the hazard has now struck the people, struck the vulnerability. So there is immediate harm is occurred to the people or community. The people were injured. They're trapped in between the debris. They cut off from the other people. The emergency response is activated through search and rescue operations. The medical aid, evacuation plans are activated, and the proper communication. So at this stage, the goal is to save lives and prevent the situation from the worsening. And the final stage, that is called disaster, the full impact has been realized. Still stage C, there may be a situation is worse, but still we are not considering as a disaster. That is an emergency. The first stage, the full impact has been realized. The widespread loss of life, destruction of an infrastructure, disruption of livelihoods, and long-term social and economic damage. So at this stage, the focus shifts to relief, rehabilitation, and reconstruction. This is the most expensive and difficult stage, which is why early warning inventions in stages A and B is so critically very important. Now you imagine what is the impacts of catastrophe, right? So the next one. So this is what about the lecture 2. So now I'll summarize. Let us now I'll summarize the both second lecture part A and part B. So let us now summarize what we have covered in lecture 2. We covered a total of 7 major topics in this lesson. The first one is key concepts of disaster. So we revisited the definitions of disaster and understood that disaster requires both hazard as well as vulnerable population. Second one is concept of hazard and comparisons with the disaster. The third one is classification of hazards. So we classified hazards as natural and man-made, direct and indirect, short-term and long-term, and finally sudden onset, slow onset, technological, war-related, and finally epidemic categories. And the fourth one is concept of vulnerability and its comparison with the hazard as well as and disaster. And the fifth one is concept on components of a disaster risk. Sixth one, how we perceive the risk perception and the identification. Final one, from 6 stages. So how we build our capacities, that is called capacity building. We define capacity as a strengths and resources of a community that help it withstand and recover from the disasters. So these concepts, mainly out of 7, these 5 concepts, disaster, hazard, vulnerability, risk, and capacity, form the foundation vocabulary of a disaster management. So everything else in this course builds upon these five concepts only. So the all coming classes are mainly rely on these 5 concepts. And finally, thank you very much. That brings us the end of our lesson 2. I hope today's lecture has given you the clear understanding of the first 5 key concepts that underpin the entire field of disaster management. So this is my second lecture. So I took feedback from many students and my fellows. So based on that, I try to improve my lecture. So before I close, let me leave you with one thought. In India, we live in one of the world's most disaster-prone countries. We face earthquakes in Himalaya region and Kutch region, cyclones on the east and western coastals, floods in the northeast and river plains, droughts in the Deccan, and landslides in the hills. But India has also demonstrated extraordinary capacity to reduce disaster deaths over the past 2 decades, that is 20 years. The reduction in cyclone mortality in Odisha is a global success story. Even other developed countries there, they visited Odisha, they discussed with the Odisha disaster management authority, and they planned many disaster management. They improved their disaster management skills. So Odisha is a global success story. As engineers and citizens, you are part of the story. Understanding these concepts is not just an academic, it is a professional responsibility. So if you have any questions or doubts about today's lecture, you can reach out to me to my email nmp560@gmail.com. I'm very much happy to clarify. So in our next lecture, we will move to the third topic of Unit 1, that is the impacts of disaster. That is, in the first lecture, I discussed brief description of social, economic, and environmental aspects. So in next lecture, I'll in detail explain the impacts. Um, so before I conclude this lecture, I just want to give acknowledge to my friend and my colleague, Dr. Sandeep, because he gave his inputs to prepare the content. So from the next lecture onwards, I'll attach his picture also. So thank you, Sandeep. Thank you, and see you in the next class. Thank you very much.